Okay. In the beginning of the chapter, I told you what we are going to cover in this chapter, right? Binomial theorem was one of the topic, or binomial expansion, basically non-terminating binomial expansion, right? And that we have covered actually, and you understood as well. Now, the most important topic. From this topic, the question began actually in the exam, partial fraction, right? As you were looking to the questions, the past paper questions, right? And you said every each and every question were starting from partial fraction, right?
Yeah.
So that we're gonna cover today. Hmm. So in partial fraction, basically what is partial fraction? Let us say if I ask you to expand 1 over x plus 1 and 2 over x plus 2. Expand as in write these two fraction, multiple fraction into a single fraction. So what you will do? Definitely you will do the cross multiplication. So it is x plus 2 times x plus 1 divided by x plus 1 and x plus 2, right? And you will get 3x plus 4 divided by x plus 1 and x plus 2. Right, so this is what the answer of this fraction. So but in the partial fraction, what we do? In the partial fraction we do opposite. I mean, from the answer we move to the question, as in the single fraction would be given to you like this, and you have to make this single fraction to the multiple fraction like this. So what is the need of this? So let us say if they ask you to expand, to use a binomial expansion, write or expand this up to x cube. So if you will do it directly, let us say if you are not using the partial fraction, if you are doing it directly, wouldn't it be difficult to expand it because there are three expansions. But if you first convert this term into partial fraction and then if you expand it, so wouldn't it be easy because there are two separate fractions, right? It is easy to apply the binomial and after that write the answer up to x cube. Are you getting it or not?
Oh, I was muted the entire time.
Hmm.
I was asking like how are we going to expand it in the
Yeah, so that,
fraction?
yes, yes. So this is actually we have to learn in this topic. So this is actually, I mean, that what we have to write in the working, right? So basically
Mm.
this would be the question. To write the answer, we have to reach to this expression. So this would be the
Um,
question and this would be the answer, right? So
oh,
whatever the working is, we have to write. I mean, for this we get 5 marks, right? In exam.
mm.
Okay. So now the types of partial fraction. So we basically have the three types of partial fraction. So I will not care about the numerator first of all, right? The only concern is the denominator in the partial fraction. I mean, whatever the variety, whatever the type we have, so only value of denominator would be changed. Numerator is not a concern for me. I'll explain you how. So we will have three different type of numerator, like, sorry, denominator, like 4x plus 5. And let us say if we have linear type of denominator, I mean all the factors are linear. Okay, this is one of the type of partial fraction. I mean this is one of the type that we have to make. I mean for this we have to make a single fraction. The another type is, one of the factor is quadratic factor, 2-degree factor we can say, and then a second one is linear. And the third type is we have one quadratic factor which we can't expand. I'm taking numerator same so that you can understand as well. There is, I mean, numerator is not a concern for me.
Hmm.
Okay. So we have three different types. I'm gonna highlight the types, the main part of the type so that you can understand. This is the main part, this is the main part, and here we have all these linear vectors. So one by one we learn all the types, and surely you will get the question in the exam. I mean, you'll get 10 marks of question, and the question will begin from this topic. In A part, you have to solve partial fraction, and in B part, they will either ask to solve binomial expansion or to solve integration. Were you hearing
Okay.
me properly?
Yeah, I wrote it down.
Okay. So now the criteria. What is the criteria to solve this question? So if we have a linear factor, we write a upon x plus 1, b upon x plus 2. So this is what the beginning step uh, of the partial fraction or of the criteria, like how we have to start it. The next steps I'll explain you one by one. If I explain you the type briefly. So for this, for type 2 criteria, we have a upon x plus 1. Okay, look it carefully. B upon x plus 2 and C upon x plus 2 square. Check it carefully, please. B upon x plus 2. So basically, there is an importance of the quadratic factor here. Linear factor, so I will write as it is. But for quadratic factor, first of all, I have to write the one power of quadratic factor, and then the two powers. I mean the second power of quadratic factor with one of the constant number like C, B. And for this, for type 3, I will write a upon x plus 1, and wherever the quadratic factor I have, I mean x square plus 3, I know I can't expand it, right? I can't factorize it. So I will write it as bx plus c divided by x square plus 3. So this is how we have to start all the types. We will do it in detail one by one.
Hmm.
And one most important point is we can't we cannot even start partial fraction a partial fraction if if power of numerator, power of variable in numerator, basically power of variable in numerator is greater than equal to is greater than equal to is greater than or equal to denominator. Denominator. So basically we can only apply the partial fraction when the power of denominator would be greater than the power of numerator. Otherwise, if the power of numerator is equal to or greater than the power of denominator, then we first apply the division method, as we have learnt in the basic integration in the fifth chapter, if you remember. There was one question.
Um,
Hmm.
but like they can be equal, right? The power.
No, the power cannot be equal at all. If the power is equal, we can't apply the partial fraction. Whenever
But
we
then
have to
like
solve the huh,
in type one, the power is the same.
no, power is not same. You can see the overall power in the denominator is 3, right? If we collect all the terms, but in numerator
Ah,
we have 1.
okay.
Okay.
Yeah.
Okay. So now one by one we discuss all the types in detail. So I'm teaching you one of the random question from here. Okay. So in this question, because all the factors are linear factors, so we will write it as a over 2x plus 1, b over x minus 1, and c over x minus 3, right? Because this is one type, this is type 1. So now the next step is multiply both sides by both sides by 2x plus 1, x minus 1, and x minus 3. Multiply both sides by 2x plus 1, that means the denominator of the left hand side, 2x plus 1, x minus 1, and x minus 3. Then we have, see, if I multiply both the sides by 2x plus 1, x minus 1, and x minus 3, so I will left with 4x square minus 25x minus 3. And in the right hand side, I will have, see, 2x plus 1 will get cancelled. Then I will have a times x minus 1 and x minus 3, right?
Um, how is 2x plus 1 gonna get cancelled?
See, if I'm multiplying both the sides by 2x plus 1, x minus 1, and x minus 3. So then 2x plus 1 will get cancelled, no? Because we had 2x plus 1 in the denominator of a, like
Yeah.
this. So then 2x plus 1 will get cancelled, and we are left with x minus 1 and x minus 3. So these two
But
are,
we are also multiplying by x minus 1 and x minus 3. So aren't they going to get cancelled as well?
but in a, I mean in the denominator of a we have only 2x plus 1. So how it get cancelled?
I mean, I don't understand, like, what do you mean by both sides?
So what two sides we have? This is the left hand side and this is the right hand side, right?
Oh, okay.
So I'm multiplying the three factors by both the sides.
Um,
Okay, let me write all the steps first. I mean the full step first, and after that maybe you understand. Otherwise, I'll explain you again. See, I'm multiplying this factor, this second factor by these three linear factors. So x minus 1 will get cancelled. So I will left with 2x plus 1 and x minus 3.
okay, okay, understood.
Okay. Now for C as well, if I multiply it by 2x plus 1, x minus 1, and x minus 3, then x minus 3 will get cancelled. So I'm left with 2x plus 1 and x minus 1. Okay. So now this equation we have. Basically, to calculate the final answer, I need the value of A, B, and C, right? If I have the value of A, B, and C, then I will substitute the value in this equation. I will substitute the value in this equation to get the final answer. So
Mm.
basically, I need the value of A, B, and C. This is my final need. So to calculate the three unknowns, I need three values of x, right? So basically, this star equation, this star equation is satisfied for the infinite value of x. I mean, I can put any value like x is equal to 0, minus 1, 2, 3, 4,000, million, trillion. I can put any value. So this equation will satisfy for any value of x. I mean, we will always get the same answer for A, B, and C. But the thing is, we have to put the values of x so that we can get the answer of A, B, and C conveniently, right? So we need the three values so that we can get the values of A, B, and C conveniently. So how we can do that? I mean, what values of x we should have to put? So uh, basically, what we have to do, we see these three factors, right? These three factors, one by one, we put all the factors equal to 0. Like if we put x minus 1 equal to 0, then we get x is equal to 1. So we can substitute x is equal to 1 here in the star equation. So we get 4 into 1 square minus 25 into 1 minus 3. See, if I substitute x is equal to 1 here, then I'll get 0, right?
Yeah.
A into 0. If I substitute x is equal to 1 here, then I'll get b into 3 into minus 2. If I substitute here, then I'll get 0, right? So then overall, what will I get? 4 minus 3, 1. So it is minus 24. Divide by minus 6. So then b is equal to 4, right? B is equal to 4 I will get. Hmm. So secondly, I can put x minus 3 is equal to 0. So then I'll get x is equal to 3. So if I put x is equal to 3, so basically one of the factor will be equal to 0 now. Two of the two numbers, the two coefficients would be equal to 0 if you put these three numbers. If you put the x value out of these three numbers. See, if I put x is equal to 3, this factor would be equal to 0. This factor would be equal to 0. And here we have the value of c, right?
Mm. Yeah.
So this is the benefit to put these numbers, these values of x. So 4 3 square minus 25 into 3 minus 3. So it is a times 0 plus b times 0 plus c uh, times.
Wait, how is a times 0? Ah, yeah, yeah. Yeah.
So it is equal to 9 into 4 is 36 minus 75 minus 3. So it is 14c. So 36 minus 78. Can you do 36 minus 78 in your calculator and divide by 14 as well?
It's minus 3.
It is minus
3.
it is minus 3. Okay. Now the last factor is x is equal to minus 1 by 2. If I put x is equal to minus 1 by 2 in the equation, then I will get 4 times 1 by 2 square minus 1 by 2 square plus 25 times 1 minus 1 by 2 minus 3. And these two factors, the values of these two factors are 0. So a is equal to minus 1 by 2 minus 1 and minus 1 by 2 minus 3. So it is little bit hard to solve this equation. Maybe you have a calculator, you can solve it quickly, but it
Yeah.
is difficult for me. Minus plus 25.2, that is 25 by 2, that is 12.5 maybe. So can you please quickly calculate the value of a using the same?
Um, it's 1.
It's 1. Okay. So the value is very simple, but the value of x was very, weird because it was in fraction. So a is equal to 1, b is equal to 4, and c is equal to minus 3. So what is the final answer? The final answer is a is equal to 1 divided by 2x plus 1, and b was equal to 4. So 4 times x minus 3, x minus 1, sorry, 4 divided by x minus 1, and the minus 3 divided by x minus 4. Okay, so this is the final answer. If you will expand this, you'll get the same answer. And order doesn't matter. I mean, you can write a upon x minus 1, b upon 2x plus 1, so it doesn't matter. Okay, so this is how you have to solve for this type. And this is one of the easiest way to calculate the value of a and a, b, and c. Okay. Okay. This is basically the second type of this partial fraction topic. So as I have explained you, what is the criteria to write it? Or what is the first step? to begin this type. So it is a over 1 minus 3x and b over 1 minus x and c over 1 minus x square, right? This is how we have to write. And the rest of the steps are exactly similar. So multiply both sides by both sides by 1 minus 3x 1 minus x square. Then we have,
Not. What about 1 minus x?
that's what I have written. No, see whatever we have to multiply with, I will check the denominator of the left hand side. Hmm? So I will multiply both the sides by the denominator of left hand side. Are you getting it?
Oh, yeah.
So I will have 4, and if I multiply both the sides by, I mean if I multiply a by 1 minus 3x and 1 minus x square, so I'm left with 1 minus x square only, if you understand it. And with b, I will write 1 minus x and 1 minus 3x, because one of the 1 minus x factor will get cancelled. And with c, I will write 1 minus 3x. I hope this is clear to you. Criteria is exactly same as the previous question. Only this
Yeah.
thing was different. Okay. So now, as we know, this equation will satisfy for infinite many value of x. I need three values a, b, and c, but I have two possible values of x here. X is equal to 1 and x is equal to 1 by 3. Okay, first of all, I'll use these two values, then I will see for the rest of the unknown. So if I put x is equal to 1, then I will have 4 is equal to a into 0 square plus b into 0 plus c into minus 2, then c is equal to minus 2. If I put x is equal to 1 by 3, then I will have 4 is equal to a times 1 minus 1 by 3 square, b times 0, and c times 0. So then I'll left with 4 into 4 upon 9a, and a is equal to 9, right? And the third one is, I can put any value of x. So I will substitute x is equal to 0, right? I will substitute x is equal to 0 because this is uh, this is most convenient value by which I can get the answer. So 4 is equal to a, whatever the value of a is, I will substitute in the equation. So 9 into 1 minus 0 square, b 1 minus 0, what was the value of b? I have to find out the value of b. 1 minus 0 and 1 minus 0 plus c is equal to minus 2, 1 minus 0. See, if I have to put any random value of x, I will start from 0. Okay. 4 is equal to 9 plus b minus 2. So 4 minus 7 is equal to b, and b is equal to minus 3 here. So the answer for this question is 9 divided by 1 minus 3x. What was the value of b? Minus
Minus
3
3.
divided by 1 minus x. And what was the value of c? Minus 2 divided by 1 minus x square. So that's how you have to solve it. Okay, you can note this down. After that, I'll give you one question to solve.